Hey guys, this is our sixth time trying this out. Hopefully I can get it to work a little bit better. I like the headphones, by the way. So, to answer a couple questions, I'm not sure how far we need to go to the material. I'm waiting to hear a little bit more from College Board. I've reached out to them and kind of give us an idea of what exactly they're expecting us to have covered, because we are a minority when we say that we do trimesters. Everybody else is in semesters. So most of the people are probably close to being done, and I hope they don't have to do a two samples test, maybe, or maybe they'll cut out the chi-square, which would be nice too. Anyway, so I'm going to finish up chapter 9 at least, and then go to either chi-square or two sample tests, depending on which one they want us to look at. Okay. So this is a copy of my notes that I've done. The presentation was really awesome, and so I didn't want to ruin the notes. Plus, I'm just thought it would be good for practice. So 9.3, we're testing population means. So if you remember from previous chapters, we had certain conditions, and those conditions were independence, which was really easy to say because usually one thing is not going to affect the other. Okay. Random, it was just going to be stated. Okay. Our 10% condition rule, our sample's got to be less than 10% of the entire population that we're looking at. That one was really easy. Then we had normality, which is large counts. And so what we had three conditions. One, they were stated that it was normal, which was really easy for us, because then we obviously could just go right into our t-test. The second one was we had to have a sample bigger than 30, and that was because of our central limit theorem. Or the third thing we had to do was we had to plot our data, and that was either we had to do a box plot or a histogram. What we also could do is a dot plot, depending on what we wanted to do. So a histogram or dot plot, they kind of give us the same thing. So then what we have, we're looking for are outliers or strong skewedness. And if we don't have any of that, then we could proceed to do our t-test. So we're going to do an example that goes over these conditions so that you can kind of see what it looks like. Or probably just quickly review as well. Alright. Let me get my face out of here so you can see it. Or not. We'll have to move that around here in just a second. So this is the example called Less Music, and this is about a classic rock radio station. Claims to play an average of 50 minutes of music every hour. However, it seems that every time you turn to this station, there's a commercial playing. To investigate the station's claim, you randomly select 12 different hours during the next week and record what the radio station plays in each of the 12 hours. Here are the numbers of minutes of music played during each of these hours. So pause if you want to write it down, and I'll move this up to here. So our numbers are 44, 49, 45, 51, 49, 53, 49, 44, 47, 50, 46, and 48. Okay, so then we are to check the conditions for carrying out a significance test of the station's claim that it plays an average of 50 minutes of music per hour. So we're going to check our four. Oops, I forgot. I apologize. So we're going to check the conditions for carrying out a significance test of the station's claim that it plays an average of 50 minutes of music per hour. So that means we got to check those four conditions. Okay? Four conditions. guys already saw most of the answers, didn't you? Okay. Independence. Each hour doesn't affect the other. Done. Easy. I don't. Yep. Okay. Random stated. I underlined it for you guys so you could see it. There's my fate. There it goes. Okay. 10% condition. So, you've got 120 hours of music played, and if we look, you can calculate how many hours there are in a week or whenever they did it, and you can see that we are well under 10%, so we're good to go. Okay. So, large counts. Number 1, did it state that it was normal? Nope, it didn't. Number 2, is n greater than 30? Nope, it's not, so we can't use our central limit theorem. And then the last one is we have to do a box and dot plot. So let me do a dot plot real quick for you. I kind of did it already. So now I need to move my picture up. So there is my dot plot. So I just drew out the numbers. I used the just set up a nice little scale. Okay. Then what I did is I used our calculator. I went to the edit and I typed in all the values that we could use, right? And then what I did is I did a stat plot. There's my outlier check. So I graph it, and remember, if it doesn't fit, you're going to hit zoom 9, and then you'll probably need to check to see if you have anything else graphed if it's not graphing. Okay. Okay. So then what I did, what I can tell from the graph is that there's no outliers. There's some, I guess you could say a little skewedness, but the data, there's not much data, so it's a little influenced and a little creaky, like my chair. So then what I did is, using the trace button, I was able to make a box plot. So there's the 44. I think this was 45.5. This is 48.5, 49.5, and then 53. So again, it shows the reader or whoever may be working on your papers that you understand that, hey, this doesn't show any weirdness. This is it's kind of normal. I'm sure if we did more data sets that it would probably become closer to normal. But right now there's no outliers, no skewedness, so nothing's going to stop us. So then I said, because the data shows no outliers or strong skewedness, we can proceed with the t-test. That is the end of our first video. We'll work on the other stuff here in just a second. But if there's anything that we can work on, I know the picture is a little grainy. I'm still working on that one, but we will talk to you in a minute, maybe with video 2.